In one of my last videos, I introduced you to Cerebro, my AI beast of a machine I built for local inference and agentic use cases. It can handle anything I throw at it, but can it? Actually, how can you tell how your machine holds up? And by the way, why would you trust some rando on the internet? I will show you how I tested my machine and what mistakes I made, and of course how you could benefit from that to test your own machine along the way. It's not hard, and depending on your use case, you could easily tweak it to fit your needs. I learned a lot while doing this and actually found something strange. I am still trying to figure it out. Maybe you have an idea, but let's not get ahead of ourselves. Before we start, what is my goal and what am I trying to test for? As you might know, I have a desktop machine with 3 graphic cards, an RTX 3090, an RTX A4000 and an RTX A5000 on an Asus ProArt X670E motherboard with a Ryzen 79050X CPU. I intend to use all the GPUs for LLM inference at the same time with different models, like for reasoning with DeepSeek R1, for vision with QuenVL, and as a general purpose LLM maybe 5.4. We'll see. I'm trying to make sure that they could handle parallel loads as well as provide enough tokens per second throughput to be useful. Especially in agentic workflows, having slow models cooperating costs a lot of time, and this basically prevents interactive use cases, so performance can be important here. For personal assistants like the one provided by Amazon, Google and Apple, latency or time to first token are also important to have a snappy experience. That's why I compare my setup to more expensive and capable cards in cloud deployments to see what performance they provide. For better comparability, I have an identical card in the cloud as a reference, and by that I can easily compare the cloud against my Homelab on sort of equal grounds. Great. So let's get started with how the test setup looks like. I have a test project linked in the description that stress tests my cards with a given set of parameters. I am always using 64 parallel requests for one test run, and I do 3 to 5 of these test runs each to get a more even result set with less outliers. I also calculate the standard deviation so we could see how much the results fluctuate. I actually do not use Ollama as the inference driver, although I love it. Ollama is just not yet made for production use. When talking about max utilization of graphic cards, others are still better, like VLLM or SGLang, and that's actually what I went for. Another constant I introduced was Llama 3.1 as the LLM. I know there are more exciting and relevant models like DeepSeek, 5.4 or Quen out there, but I want to test my hardware performance and not the LLM. I have older tests with exactly this LLM and want to be able to compare these, hence my consistent requirements. Now, coming to the hardware in the cloud. The competitors I compare my system with is another 3090, the RTX 6000 and the ADA version of the RTX 6000. I don't want anything higher tier than that because even the ADA card is way above my buying budget. Your mileage might vary, but my goal is to see how stark of a performance difference I get by using my hardware compared one would use in a more professional but not enterprise segment. Here the A6000 cards are basically the standard, and without any Blackwell chips out there in the real world, this is the latest GPU generation you can get. ADA lawless, that is. Obviously you could simply try other cards as well. There are samples in the repo on how to run SGLang server on Runpod yourself. It literally takes you like 2 clicks once you're logged in and you're up and running serving requests in less than 5 minutes maybe. The barrier of using such infrastructure is so low, especially for testing. I paid for my testing around $5 and I had to redo a lot of tests, figuring out how everything works, debug stuff and so on. Just make sure you shut everything down once you're done and only work with prepaid credits. You could use any other provider, obviously. This is not an endorsement at all. I don't earn anything if you use them. They are just the one I use. That's it. Enough with the theory. let's look at the results. In the first graphic, you see the token generation throughput by GPU and data type. I didn't mention it, but I ran the test with two quantizations of the same model. One with BF16, that is obviously bigger, but better supported natively by the GPUs. See, like the blue bars. And another FP6 version that is smaller, but requires more computations. The orange bars. Right here you could see the first gotcha. Stating Captain Obvious, the RTX A4000 couldn't load the BF16 version of the model due to the lack of sufficient VRAM. 16GB was just not enough. The second thing to note is that the two 3090s perform pretty well, given the much more expensive competition, outperforming the A6000, which is on the same chip generation, Ampere, and trailing the new Ada Lovelace generation slightly. Talking about bang for the buck? This is great. Also, the difference between the local 3090 and the cloud version is tiny. If anything, the local version is faster. There are no round trips to the internet, obviously. As a consequence, it's safe to assume my local setup is not too bad for the given GPU. I could utilize the full potential, at least when running on one GPU at a time. Another interesting to note here is the standard deviation of the A6000. When looking at the core data, we see that the first run was an outlier that impacted the results. So, what else does the graph tell us? We can get consistently above 600 tokens per second on every card, and with the A6000 Ada version, even about 1000 tokens per second. Also, the smaller FP8 version is significantly faster than the natively supported BF16 version. Let's look at the tokens per second on a request basis. This is the same test, but now we are looking at how many tokens per second each individual request got and not the sum of all the requests. Here we see the A6000 and A4000 are noticeably worse with the FP8 model compared to the other. BF16 performance is basically identical on a per generation basis. The other card is slightly better considering the standard deviation. Lastly, we look at another metric that is particularly important for personal assistants and time-critical applications. Time to first token. This is a mess. The standard deviation indicates that there is something going on, and the fact that the first response took sometimes well over a second, that's bad. Really bad. Before jumping to conclusion, just remove the slowest test run and see if the results normalize better. With so few test runs, remember 3 to 5, one outlier could skew the whole dataset. Now look at that. The first token is consistently below half a second, and we do see the impact of the network. This is in fact the first really important lesson. If you do want or need to optimize for responsiveness, proximity to your LLM compute is measurably crucial. Looking at the other graphs for the cleaned up data, we see the standard deviation became really low, except for the A6000 FP8 model. I assume this is more related to either network or server issues and not being a general issue. But this would be something you would explicitly test and build test cases for. For production workloads, you don't want this kind of uncertainty if this matters for your business cases. For me, as a test bench, I don't care. Discarding the A6000 FP8 results for a minute, all GPUs perform pretty similar, except the A4000. Now, you might say, boah, this looks pretty disappointing, right? Well, in contrast to others, this card not only has 16GB of VRAM, it also only consumes 140 watt and is a one-slot card. This is almost a third of the 3090 regarding slots and power consumption. For that, I think the performance is rather great. Now, does this card make sense for you? I don't know, but now at least you know what you're getting. With these results, it's way easier to make an informed decision, right? And talking about impressed, I'm really impressed with the A5000. It draws just 230 watt compared to the 350 watt of the 3090, is only slightly slower and delivers extremely consistent results. This looks like a very reliable piece, and I am happy I took the plunge and got myself one used. Awesome. Now I know that my Homelab is comparable with a cloud solution. Well, it might even be better depending on the use case due to the lower latency. The new question I ask myself is, what if I stress test all three of them in parallel? Obviously, I could only run the FP8 version of the model to utilize all three cards because the BF16 didn't fit the A4000. Looking at the results, three strange things happened. First, my model performance got significantly better out of the blue. It was a few weeks later, but I otherwise didn't change the setup. I updated my system and I pulled the latest LLMs from scratch, but that's it. I think I hit the FP8 support added in SG-Lang version 0.4.1, but I don't really know. The result is awesome. More than 200 tokens per second increased performance for free is great. But the feeling that I made a rookie mistake and changed the test environment really annoys the crap out of me. Although results are great and testimony to the developers, I guess, because I don't know for sure. Not great is the second thing. The performance hit when running in parallel. Something between a fourth and a third of the performance is lost when running in parallel. Nothing that causes sleepless nights for me, but it is undeniably there. The third thing is a constant beep of my server as soon as I start the benchmark stressing all 3 cards in parallel. I first thought it might be temperature or power problems, but I couldn't find any definitive proof. The Mainboard manual was also not helpful, and I couldn't find any useful resources where to find relevant error logs. Everywhere I looked, nothing came back. So if you have an idea, I'm all ears. Okay, the throughput took a hit. What about the other metrics? The tokens per second for the individual requests remained stable and didn't change for my last test, so this is great. The first time till token, however, did got hit noticeable, but still remained better than the cloud variant. Oh, and talking about the cloud, I thought it would be interesting to do the same test against the cloud. Now, before you call me a moron, I am well aware that running a stress test for a single server won't work for the cloud because there's no single server. However, I did want to test 2 things. First, is the cloud now faster too? And second, might my load driver be just too weak and can't saturate the demand of the 3 cards? On top of that, I did something else, which in hindsight wasn't great. But I thought I'd test all cards in parallel, which I tested previously. Not only the 3 I have, but also the A6000 cards. My rationale at the time was that because the server hosting the load driver now didn't have to handle the receiving of the load, this shouldn't impact anything. Boy, was I wrong. In the graphic, we see that indeed it looks like an issue with the load driver, because we see drops in performance that otherwise wouldn't make any sense in a distributed cloud environment. The overall performance got better compared to my old tests, but not as significant as in my Homelab. 1100 compared to 1200 for the 3090, for instance. During the test, my machine didn't beep and the traffic didn't hit the maximum upload speed limit of my network. So these were good, but also caused me some headache. See, I had expected the time to first token to be not affected in case the load driver has an issue, but the results tell something different. There is clearly a hit in the parallel runs. Yeah, a mess. By now you are probably wondering, why am I telling you all that? Problems over problems. First of all, I think it's easier to learn from mistakes. It is also more honest. Nobody's perfect. I tried to do some testing without spending too much thought about it, and it got really messy. Now I'm sort of stuck with unfinished business because I don't know how to really explain the parallel behavior and my stupid beeping mainboard. Again, if someone knows what's going on, please let me know. I put all my scripts and tools to visualize along with the results in a Git repo, so just go ahead and check it out. The link is in the description down below. Here's my conclusion as a self-reflection, if you will. First, my setup, although I identified issues, is working more than satisfying for my use cases and needs. I'm not going to run more than 60 threads in parallel against my server for each GPU, and even if I would, the performance is more than adequate for me at the moment. As for the open ends of not answered issues, I accepted that I might not solve them, and that's fine, because even if I do, other than satisfying my curiosity, I don't gain anything that is worth spending more time on it. Sure, I want to know the answer, but I have so many other things I want to do, and time is one of the rarest resources, so I do have to choose wisely. And this is exactly the message I want you to take home. Try not to win every battle. I know this is hard at times, but rather choose wisely where you spend your precious resources. If you like seeing me failing doing stuff, watch this video again. Otherwise, subscribe for more, and if you enjoy it, leave a like. In case you think I'm a moron, the other one works too. I totally understand. Signing out, till next time. Servus.